Hi students, let us start with electrostatics. What do you mean by electrostatics? Electrostatics deals with stationary electric charges. Statics means stationary. In this session, we will learn about Coulomb's law. To learn Coulomb's law, you consider 2-point charges, stationary charges, say Q1 and Q2, separated by a distance r. These two charges are separated by a distance r. In diagram A, Q1 and Q2 are positive. They are like charges. Like charges repel each other. They are repelling each other. This is the repulsive force between these two charges. In diagram B, Q1 is positive and Q2 is negative. They are unlike charges. You know that unlike charges attract each other. This force is attractive in nature. Like charges is repulsive and unlike charges it is attractive. Coulomb's law gives you an expression for this force F. Please note that this force is always acting along this line joining the centers of these 2-point charges. This force is acting along this line. According to Coulomb's law, this force is directly proportional to the product of their charges. It is inversely proportional to the square of the distance between them. Combining these two expressions for the force, you can write F is equal to Q1 Q2 by R squared. F is proportional to Q1 Q2 by R squared. Next step is to replace this proportionality sign with an is equal to sign. Whenever you replace a proportionality sign with an is equal to sign, you have to put a constant. The constant here, it is K. Therefore, the expression for F becomes F is equal to K Q1 Q2 by R squared, where K is called the constant of proportionality. For free space or vacuum, this K is given by K is equal to 1 by 4 pi epsilon naught. This is called epsilon naught. We will learn about this epsilon naught in another session. Epsilon naught is called permittivity of free space or vacuum. Therefore, how can you represent Coulomb's law mathematically? Coulomb's law can be expressed as F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R squared. Replace this K with this value 1 by 4 pi epsilon naught. This is the mathematical expression for Coulomb's law. Coulomb's law F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R squared, where epsilon naught is called the permittivity of free space. This epsilon naught is the absolute permittivity of free space. Its value is 8.854 into 10 raised to minus 12. We will learn about this epsilon naught in another session. Don't worry about that. 1 by 4 pi epsilon naught value is 9 into 10 raised to 9. Therefore, F can also be written as F is equal to 9 into 10 raised to 9 Q1 Q2 by R squared. Coulomb's law states that force between the 2-point charges. This force is directly proportional to the product of the two charges and inversely proportional to the square of the distance between the charges. Directly proportional means what? If Q1, Q2 increases, F increases. Inversely proportional means what? If R increases, F decreases. This Coulomb's law is also known as inverse square law. This K is the constant of proportionality and it depends on the medium. For free space or vacuum, the K value is 1 by 4 pi epsilon naught. This epsilon naught is called absolute permittivity of free space. The value of 1 by 4 pi epsilon naught is equal to 9 into 10 raised to 9. Therefore, you can write F as 9 into 10 raised to 9 into Q1 Q2 by R squared. That is in Newton, the unit of force. What do you mean by vector quantities? Vector quantities have both magnitude and direction. Therefore, we will write Coulomb's law in vector form as force is a vector quantity. In vector form, you will be including the direction also in addition to the magnitude. Let Q1 and Q2 be two positively charged particles. Q1 is positive and Q2 is also positive. If you have two like charges, they will repel each other. Q1 will exert a force on Q2 and let that be F21. And Q2 will exert a force on Q1. Let that force be F12. F12 means the force exerted by 2 on 1. This is on and this is by. Force exerted by the charge 2 Q2 on the charge Q1. That is the meaning of F12. Therefore, what will be the meaning of F21? The force exerted on Q2 by Q1. The force F in vector form you can write as F12 or F21 in vector form, showing the direction. The magnitude of F12 will be 1 by 4 pi epsilon naught Q1 Q2 by R squared. And also the magnitude of F21 is also 1 by 4 pi epsilon naught Q1 Q2 by R squared. Here the 2-point charges Q1 and Q2 are separated by a distance R. This distance R from Q1 to Q2 can be represented using the vector R21, or you can use R12 also. Here I am using the notation R21 to indicate the distance from Q1 to Q2. To indicate the distance from Q2 to Q1. This distance I am using the notation R12, this vector. This R21 and R12, these are equal and opposite. These vectors R21 and R12 can be represented using the unit vectors in order to indicate the direction. Whenever you are using the unit vectors, you must put a cap on the top of that R to indicate the magnitude. It is unity. Unit vectors will be having the magnitude 1. Once you have the direction, you can easily represent Coulomb's law in vector form. F21 is the force on the charge 2 due to the charge 1. F12 is the force on 1 due to 2. When you consider the force on charge Q2 due to charge Q1, you must consider this distance, which is R21. That is why you are using R21 in the place of R. This gives you the magnitude of the force. Multiply with the unit vector and this gives you the direction. F12 is the force on Q1 due to Q2. Therefore, you must consider the distance from Q2 to Q1. This distance is R12. Therefore, in the place of R, you must put R12 the whole square. This value gives the magnitude and this unit vector will give you the direction. R12 and R21 are equal and opposite. Therefore, you can substitute this value in this expression and you will get F12 is equal to minus F21. We know the Newton's third law of motion. For every action, there is an equal and opposite reaction. This Coulomb's law is also agreeing with that F12 is equal to minus F21. In this session, we learned about Coulomb's law. Coulomb's law states that the force between two point charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Mathematically, it is represented as F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R squared. This force can be either attractive force or repulsive force depending upon the charges. As force is a vector quantity, we can represent this law in vector form also. The value of 1 by 4 pi epsilon naught is 9 into 10 raised to 9. Therefore, F you can write as F is equal to 9 into 10 raised to 9 Q1 Q2 by R squared. Coulomb's law in vector form is represented like this. This unit vector gives you the direction. Hope you understood Coulomb's law. Thank you.